All right, a sample of 60 night school students' ages is obtained in order to estimate the mean age of night school students. The result is the sample average is the sample average is 25.3 years. The population standard deviation is 4. Find a 95% confidence interval for mu to 2 decimal places. That's supposed to be mu. So that's the actual population average versus the sample average. So population mean versus sample mean. All right, so here we go. So we go to the calculator. We choose stat, and we do test, and we want to do a z interval. So we want to do a z interval because we know the population standard deviation. Not a t interval, that's the next one. We're doing a z interval. So we do z interval, and it's based on stats, not data. It's the standard deviation is 4, and the average is 25.3, and n is only 60. So only 60 people. 95% confidence interval, and we calculate. So we get 24.288, 289 to 26.31. That's my confidence interval. That mu is between these two. So I'm 95% confident mu is between these two numbers. That's it. The next question is how large of a sample do I need to do? And that comes from this formula right here in the formula page. So sample size is the z-score squared, standard deviation squared, and the EBM squared. So n is equal to the z-score squared, the standard deviation squared, population standard deviation squared, and the error bound squared. All right, so how many people should I talk to estimate 99% confidence interval within $75? So $75 is the amount of error that I want. So I want to have $75 down here, and that's going to be squared. The standard deviation is $900, so 900 goes here, and that's squared. And then I need the z-score for 99% confidence interval. So to find the z-score for that, it's not one of the common ones, right? So the z-score for 90% and 95% are just those. We keep using those all the time. So what we need to do is we need to go to the distribution, so second distribution, and we go down to inverse norm. And I want 99%, so 0.99, and I want that in the center. And we can go off the standard normal curve just to find the z-score. I don't need to adjust that. I just want to know the z-score for 99%. On the older calculators, you'd have to do 0.995 because there's a 0.5% in each tail, because the inverse norm only goes from the mark all the way down on the bell-shaped curve. So for this calculator, 99% in the center is 0.2. What did I use for my answer key here? I did 258. I rounded up to 8, so I did 2.58. All right, that's right here, 258. So it's between those two is 99%, and that gets squared. All right, so 2.58 squared, and then we have times 900 squared, and then we're dividing it by 75 squared. So I got 958 and a half, and you should really go up to the next whole person. All right. The next question is based on data, not stats, and it's an unknown population standard deviation, so I'm going to use the student's t-score. So let's see, I have to put the data in first. So I'm going to go to Stat, Edit, hit the Stat menu, Edit, and then put the data in. And I've already put the data in, 5.2, 6.4, 3.8, blah, 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 all the way down to 4.7. Oh, I got it out of order there at the end. And this is, the new Accelerate is supposed to speed up the drawing process more than 4%. These were the 8 tests that we did. So if we did 8 tests, 8 minus 1 is 7 degrees of freedom. It's always minus 1 or your degrees of freedom. And so we want a 90% confidence interval. So when we calculate this, it'll spit those two out automatically for us. So we go back to Stat, and we do tests. And now we're doing a T interval because the population standard deviation is unknown. So we do a T interval, and we go off of data instead of stats. And the data is in L1, and the frequency is 1 because the numbers happen once. And 95%, so we put in 95% confidence interval, and we click Calculate. And it brings it back to 3.442. Uh-oh. Not getting the same answer. What happened? 3.44 to 5.6, 5.68. All right, so hang on a second. Hang on a second. So something weird happened. Hang on a second. Oh, I see what happened. It's a 90% confidence interval, and I think I did 95. So let me go back and change that again. So Stat, Tests, T interval, boom, 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 90%. There we go. Not 95, 90%. Calculate. Okay, there we go. So it's going to be 3.66 to 5.46. That's my interval. So I'm 90% sure that the 4% is going to be between those two. So they're claiming 4%, and that's the target value. So I'm 90% sure that the real average is between those two. So it could be below 4%. You know, it's kind of a crapshoot. We really need more data on this. Answers for free, so it's going to be 4.5625, and the standard deviation, your sample standard deviation SX, is 1.34. Okay, so this number here is the average of all those, and then this is the sample standard deviation off of those numbers. You can also find these answers by doing Stat, Calculate, and then you just calculate a one variable statistic on L1, and it spits these numbers out. Like there's the average, there's the sum of the numbers squared, the sample standard deviation, and the population standard deviation, and there's 8 numbers. All right, population proportion. So this one here, so it's 11, or not 11, it's 110 out of 250. All right, so we divide those. So 110 divided by 250 is 44%. So this is our sample, 44% have a checking account and a savings account. So we're going to have a 95% confidence interval. The true proportion is going to be, you know, somewhere in a range around 44%. So this is where we do the proportion test. So we go to Stat, and we go to Tests, and then we choose A. A is one proportion z-test. So for these, it is or it isn't. You have it or you don't have it. So that falls under the normal distribution, which is your z-scores, not your t-scores. So we go to here, and so X is how many people are have the both things. That's 110, and then we're going to do 250 is how many we talked to. We want to be 95% confident, so I'm going to change my confidence interval to 95%, and then we just do calculate. So 37.8, 3 decimal places. 37.82, that is 3 decimal places because I'm doing it in percents, to 50.2%. So I'm my actual true proportion, I'm 95% confident, right? I'm 95% confident that I'm between these two. My survey said 44%. So it's basically plus or minus 6%. So my margin of error is plus or minus 6%. That's 95% confident. All right, now we want to do how many blue-eyed people there are. So this is a different formula. It's this formula right here for section 9.3. It's the z-score, p hat, q hat, and then your margin of error. So n is equal to, the z-score for 90% is 1.645, and we square that, just follow the formula. We don't know what we're looking for. It could be 50%, 40%, or whatever. So what we do for this is we default to 50% for and 50% against. And then 90%, we want to be off by 2%, so we're going to divide by 0.02 squared. So that follows the formula. We got the z-score, for and against, and then how far off we want to be. So we type all this into the calculator. 1.645 squared times by 0.5 times by 0.5 divided by 0.02 squared is 1,691.27. So we really should talk to 1692 because you always want to round up. And that's the answer to that one.